Well, g'day, flatties and reality defenders. This is the legendary Critical Think from Down Under. Thank you. Today we're going to talk about how a pea-brained flattie brings buffoonery to a science fight with the legendary Critical Think. Now, YouTuber pea-brain, he's got his knickers in a knot over the final experiment. It's just video after video after video. He's really been triggered by the final experiment. Now, I'm lucky enough to get myself featured in 1, 2, 3. We've got here, this one's got my face on it. This one's got my face on it. And you can't see there, but I'm in the title there. So living rent-free in pea-brain's head at the moment. He's really triggered by the fact that we went to Antarctica, and I've got some good evidence for the globe. And so when we were in Antarctica, we were talking to some of the other flat earthers there, and they expressed some concern that we as globers often poked fun at flat earthers, and that they said they didn't like it. Well, so, you know, it was more or less indicated that we should have a more reasonable approach to approaching the debate. So pea-brain's posting some stuff that's obviously incorrect. So I thought, I'll go on his channel and I'll make a few comments and try to point out where he's wrong, you know, engage in an adult conversation and see what will happen. Well, as it turned out, being Mr. Nice Guy was not so good. So in response of me trying to be Mr. Nice Guy, pea-brain let the ego get the better of him, and he's there, 1, 2, 3, bang, there's all these videos, and you know, I take my time with putting out a response, and I informed pea-brain that I would put out a video response. So he's been furiously uploading videos ever since that. I don't know why he thinks that will help, but the point is trying to engage in a rational conversation with flat earther seems to be a useless exercise. So don't blame me if I'm going to be a little bit sarcastic and I'm going to make fun of you, pea-brain, because I did approach this first with a non-combative style and just trying to inform you where you went wrong, and you couldn't help yourself, could you? You had to make these ego boosting videos. Well, anyway, here's my critique, and here am I pointing out how, pea-brain, you've got it wrong. So what's wrong here? I'll just give a summary of that. So pea-brain ignores all science. You know, we've just been to Antarctica. Pea-brain thinks the final experiment was one experiment. Oh, just looking at the sun. Oh, yeah, it's there for 24 hours. No. Although that is a very powerful thing, we actually had about 16 experiments, and we had globe predictions for all of them. And guess what? All the globe predictions were correct, and the flat Earth predictions, none of them are correct. So pea-brain to say, obviously, Earth is not a globe, and obviously it's not spinning, it's absolutely ridiculous in the face of the evidence. So he's starting out on the wrong foot already by declaring that the Earth doesn't spin, especially since I've demonstrated that the oblateness and the spin do account for 100% of the variation of weight measurements as you go around the globe. So we know that pea-brain is wrong. All science says that he's wrong, but somehow he thinks he knows better than everybody. Somehow pea-brain gets on his horse and says, oh, no, the Earth cannot be rotating, blah, 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 blah. Anyway, so that's ignoring all science. He uses cartoons. Now, pea-brain is a very good illustrator. I envy his skill there. He has a skill there. He should stick with it, because as a science influencer, he's a dismal failure. Right? He doesn't know anything about the globe, doesn't know anything about science, and yet he's trying to teach other people about it. So this is, you know, just a little bit disgusting, really. You should not be teaching what you don't know. Now, in P-Brain's videos, there's also no application of real science, no understanding of the globe model, no calculations or measurements. It's just a thought experiment and cartoons. And here's this here confusion abounds. He doesn't understand how force and velocity are different and how they work as vectors. He doesn't really understand Newton's first law, although he does invoke it. He's unfamiliar with how gravity and centrifugal forces coexist, and he does everything in 2D and really doesn't have a good understanding of the 3D. Now, this here just sort of like illustrates some of the comments about how we got started, and you'll see something in there with P-Brain declares that a lake debunks the rotating Earth. So at first I started mentioning about if you've got a glass of water on a plane that's travelling at 900 kilometres an hour, then the glass of water, the water doesn't jump out of the glass. And so he then chastises me on this and saying that there's a colossal difference, and that when you're at a latitude line of say 45 degrees north, you're actually turning to the left at 500 miles an hour. So which my reply is, okay, so the plane makes a bank to the left. Does the water still jump out of the glass? No, it doesn't. But anyway, it went on from there, and a lot of the points will be covered as we go through this. So let's listen to a bit of this.
Hey everybody, this photo debunks the final experiment, which is really an observation.
So like I said before, it wasn't just one experiment, it wasn't just an observation, it was many experiments. And P-Brain's thinking that this picture debunks it. He is mistaken, and we'll go into that why he is mistaken.
This picture debunks it, because this picture of a glass-like mirror water shows that there's no spin to the Earth. The Earth is not a rotating ball.
So here, like I said, he's already declaring that there's no spin, and he has his reason, but we've already, through our experiments, determined that, yes, there's plenty of evidence for spin. And even before we went on the trip, the final experiment, there was much evidence of spin. It's just that flat earthers cannot accept scientific evidence, and they just deny it.
So their little experiment is reliant on a rotating sphere. That's what they're trying.
I'd just like to correct you there, P-Brain. Our experiment doesn't rely on a rotating Earth. Our experiment demonstrates that the rotation is real. So it's not you put the cart before the horse there. No. Our experiments demonstrate that the rotation is real. We don't require rotation. We test for it, and the tests come out positive.
Trying to prove with their footage. Whether it's fake or real doesn't matter. If a ball was actually rotating, and remember, this rotating sphere is said to have an equatorial bulge of 14 miles high. That's right now, people. That's a 1,000-mile-per-hour spin around the equator.
So
the Earth is bulging upward 14 miles high at the equator. This is what they said. This goes all the way back to Newton. Okay,
that's correct.
That's ground. That's rock, dirt, beyond measurable weight, lifted up 14 miles high. Yet, look at this water. Okay, when the wind's not blowing, you can get water like this anywhere on Earth. Dead still like a mirror. That's it. Earth is flat.
So that's because you don't understand how equilibrium works. I know you've had a couple of attempts at explaining it because people have mentioned equilibrium to you before. But really, no, I'm going to explain a little bit more about how this can occur, how we can be rotating, and at the same time this lake be still. So we'll get to demonstrating that a little bit later on.
There's only one place on a sphere where you go absolutely in a straight line, that the momentum of the rotating Earth would push you in a straight line. That's the equator. That's it. Everywhere else on the sphere, you have to turn. In the northern hemisphere on a east.
So here's the part that's a little bit difficult to understand where he's coming from. And I did try to tackle that, and we'll see what happened after that. But basically this is a 2D representation, and it's a misunderstanding of the forces, and we'll get into that, why I disagree with this.
Word rotating Earth, you would be forced to turn to the left. In the southern hemisphere, you would be forced to turn to the right.
So just one little thing, all of these are circles. Some circles are smaller than others, but they are all circles, and they are all rotating. So I personally would not say that some of them are turning to the left and others are not, because they are all geometrically equivalent. So even if the tangent to the surface is at a different direction on each of these circles, the point at which it's the latitude line is a circle rotating in a circle. So I don't make, it's not the distinction between latitude lines and the equator is not really that important in the analysis. It becomes important when you evaluate the centrifugal forces. So this here is a very confusing graphic, and it doesn't take the forces into account.
Water and everything else wants to go in a straight line. This is why water moves to the equator.
So water does have a force that moves it towards the equator, but it's not the force that he's describing here exactly. So the water tending to move in a straight line, in fact, the water is turned around the globe by the centripetal force, which is gravity. So the inertial force, which is like related to Newton's first law of motion, the inertial force is what generates the centrifugal force. Now, the centrifugal force is not as great as P-Brane is trying to make out here. So we'll analyse the forces a little bit later, but this is a completely false depiction, completely misleading about what's happening with the movement and the forces.
Of a rotating ball, a wet ball with water in it, the water always moves to the equator. Try looking this up.
So this is a complete joke, and he should stop doing this because it makes him look very silly. So this ball here is rotating maybe 100,000 revolutions per day, or probably more. And so the forces are all different when you compare to 1 revolution per day. So there's not only is the ball of a much smaller radius than the Earth, it's also rotating much faster, 100,000 or more revolutions per day, and he's trying to compare it to 1 revolution per day. That's pretty silly, P-Brane. That's ridiculous.
Try finding an explanation of how the water and why it moves to the equator of a ball. I couldn't find it. I spent at least a half an hour looking online.
I'm sorry if you couldn't find it, P-Brane. Don't worry. I'll explain it to you here today. So, your search is over.
I couldn't find it. But I can give you an explanation, and I'm sure I'm going to get some people who get me riled up enough to put out the explanation. I'll tell you exactly how it works. All right? This dead still, mirror-like, glass-like body of water. Done.
So, perfectly explainable on a rotating globe that rotates at 1 revolution per day. Well, anyway, let's carry on.
So, this critical think comes along, and he describes the sphere as a cylinder as well.
Not like that.
But they're tricky. They try to do a hybrid. They try to combine the two. So that's what I'm going to show you here. So here's a quote from our little debate. So here he is thinking that I don't understand that he's incorrect. All right?
No. P-Brane, you don't understand that you are incorrect. But anyway, carry on.
So he says, Think of a sphere, P-Brain, as a cylinder of increasing radius, like this Spherelinder that I have here.
No. That's your interpretation. That is not what I said. That is not what I mean. This is just your interpretation. So rather than just, ask me about what I'm talking about, what I mean, you go rush out to go make a video. Oh, look at me, look how good I am. And then you just make these silly diagrams. So we'll get to the correct interpretation in a little while. I'll show you what I meant. That's not what I meant.
That's exactly, he's describing my Spherelinder to a T.
No, those are not very thin cylinders. So no, I'm not describing that.
Okay, that's from Critical Think. Each latitude can be considered a very thin cylinder?
Yes.
Now, you see this picture? I have the little man, okay, this little yellow guy on the Spherelinder. That's what he's describing.
No, that's not what I'm describing. Sorry.
Very little thing would work. With gravity located at the pole, everything could rotate around and stay put. So just let me remind you, on a sphere, the ground wants to turn out from under you. And I'll just talk northern hemisphere. In the north, as the Earth turns east, you would have all this water and air.
So here's another mistake he's making, is thinking like the water has a mind of its own and it's not subject to the forces that it is subject to. So he's thinking the ground would spin away from under the water. Now, this is very much similar to the old the Earth must rotate under an aeroplane, absolutely bonkers flat Earth argument. So he's trying to resurrect this argument, which shows no understanding of the forces involved, doesn't understand conservation of momentum, doesn't understand that the gravity is causing a centripetal force, which is also causing the water to turn. The ground does not spin away from under the water. And this is completely false. There is not a 500 mile per hour momentum happening in that direction, and it's certainly not making the water flow downwards towards the equator. The forces are all a little bit different, but let's carry on.
Everything would be moving with the ground, but the ground is making a left turn out from under the water. So the only place you traverse straight on this sphere, the only place that the ground traverses in a straight line is the equator. Everywhere else on the sphere is a turn. So the ground is trying to turn to the left, which is east, right? Eastward.
The way I'm going to show that the ground is still doing a circle, so I know why. Now I know why he thinks that's a turn to the left, but we'll get into that.
It's rotating around, but everything else wants to go straight. So when the ground rotates out from under your water, you have turbulence. And so that's what you would have. Hundreds of mile per hour moving water would want to move in a straight line.
This is what he thinks the lake should do.
First law of motion. An object will tend to stay in motion at a constant speed and in a straight line unless there's something to act upon it to change.
So he talks about, he's trying to sound all scientific here and try and talk Newton's first law of motion. And of course, none of the flatties understand any of this, so they'll think he's very clever with this. So it is true, an object at rest remains at rest, or, if in motion, remains in motion at a constant velocity. And let's not ignore the next bit, unless acted on by a net external force. So that last bit is because when something might be sitting on the ground, it's being acted on by a force of gravity pulling it down to the ground. Now, if you left out that last sentence, if you had something would drill into the ground because it's got a force that's acting on it in a downward direction. But of course you also have the ground pushing back up. So that is, it has got a force pushing it up, a force pushing it down. There's no net external force, so it doesn't move. So a brick sitting on the ground doesn't move. even though it has forces acting on it, there's no net external force. And this is exactly the same situation with the lake. And we'll get to demonstrate that. And the reason the lake does not move and rush to the bank and slam into the bank and waves go everywhere, the reason is because there's no net external force. We'll get to that. This is the P-brane idea of what a Spherelinder is, and this is not what I described. I did in fact ask ChatGPT this question because it's funny how a computer program like ChatGPT is probably 1,000 times or more smarter than a flat earther, but anyway, that's the way it is. So I asked the question, can a sphere be considered a collection of ever-widening solid cylinders? Now, I had to use the word solid there because I wanted to describe them as discs, cylinders and discs, solid cylinder and disc, similar thing. And because ChatGPT thinks that a cylinder is just got a skin and it's hollow, so that doesn't work. So we've said a solid cylinder. And what does ChatGPT say? Yes, a sphere can be thought of as a collection of ever-widening solid cylinders if you construct it in the right conceptual framework. Well, obviously P-brane has not constructed it in the right conceptual framework. So you can imagine slicing a sphere horizontally into thin cross-sectional discs. Okay, isn't that what I said? That's what I said. Thin cylinders. Discs and cylinders are the same meaning here. Each disc has a radius equal to the distance from the centre of the sphere's vertical axis to the edge of the sphere at that height. It's exactly what I said. A thickness equal to the height of the slice. So I'm talking about very thin slices. You can do that. It's a concept that is perfectly valid. So each of these discs can be visualised as part of a solid cylinder. So when you build the sphere, you start at the bottom of the sphere where the radius of that cylinder is 0, and you move upward, gradually increasing the radius of the cylinders as you approach the equator. Now, isn't ChatGPT just a little bit smart there? How does ChatGPT know what I mean, but P-brane doesn't? How about that? So beyond the equator, the cylinders start shrinking in a radius symmetrically until they taper to 0. So that describes the way of thinking of a sphere as a stack of ever increasing and decreasing solid cylinders. So it's not such a strange concept, P-brane. Not so unusual. Calculate the radius of each of these very thin cylinders. And this concept works for visualization. And a true cylinder has a flat top and bottom, whereas the cylinders that make up a sphere would technically need to have curved edges. Yes, that's correct. So we'll talk about the so-called chamfered edge cylinder a little bit later. So the idea is useful in integral calculus. Okay, so that's not such a dumb idea. The sphere modelled as a series of very thin cylinders. Not such a dumb idea. ChatGPT agrees. So, P-brane, you're the only one with the problem. So we'll take a look at this in 3D, because it all works much better in 3D rather than in 2D. Okay, I've got here a very rudimentary 3D model. I didn't want to spend a lot of time on this, so it's not all that professional looking, but it will do. So what I've done here, I've drawn a 60th parallel line of latitude here. I've drawn a great circle line at this tangent, and I've got another torus object that is the equator. Now, P-brane likes to say that all great circles are straight lines and latitude lines are turns. Now, some of the literature does sort of say that, but to me, they're all circles, right? Every one of them is a circle. So why is one turning and the other one not? I don't get it. For example, P-brane, this is the velocity vector. This one here, which is marked, this is the velocity vector of anything that's rotating on the Earth. Now, as you can see, if we zoom in a bit, the velocity vector and this latitude line, they are a straight line when you look at them side on. And this is a great circle, is a turn when you look at it side on. So a circle is either a straight line or a turn, depending on whether you're looking at it edge on or not. So that delineation is not useful in this case. You've got to look at the forces, the directions of the forces. So this is the instantaneous velocity at the point, the tangent point right there. And its direction is in the direction of the turn or the latitude line. So this is why I said you can consider this as a very thin cylinder, and the direction of rotation is the velocity is along there. So if you were to ignore the centripetal force, and there is one, but if you were to ignore it, the water would be flung in this direction and not towards the equator. But the term flung is a little bit harsh because of the forces involved here. Now, P-brane thinks that the water would go straight ahead because of Newton's first law of motion. But he's forgetting about the other forces that act on the water. And so there's this big force of gravity. And this gravity vector, I've put it there that length so that I can compare it to the centrifugal force. So it's acting towards the centre of the Earth. You can see that one. So that not only is it pulling the water to the ground so that it's not going to fly off the Earth, it's also pulling it towards this, keeping it travelling in a circle. So the force of gravity keeps that water travelling in a circle. Now, there is a small force that pulls the water towards the equator. You're not entirely wrong about that, but the mechanics of it you totally do not understand. So I'm going to, I've drawn another vector. It's a very small one, and this one here, this vector I've drawn here, if you just take into account this portion pointing towards the equator, ignore this part of the line for now, but this is 10 times the size that it should be. So if this is the size of the gravity vector, which is 9.8 newtons, the force pulling the water towards the equator is 0.0255 newtons. So that one there is 0.2, not 0.02. So you can see that the force pulling the water towards the equator is, 0.2% of the force that's pulling the water towards the centre of the Earth. So there is a very slight sideways pull, and that is exactly why the equator has a bulge. That's why it has a bulge, because of this force. And what you don't understand is the bulge causes equilibrium. It causes a balancing of the forces. Now, it's a little bit difficult to understand, but I've got a little bit of a visualization coming on. So it's not like that the water is being pulled towards the equator at 500 miles an hour. So that's completely wrong. You're confusing velocity. You're not considering the forces. So there are forces that are causing that water to turn in a circle, right? And there is a very small force that causes the water to move towards the equator, which is why the Earth has a bulge at the equator. Now, flatties, you're very well aware of the concept water finds its own level. You'd be surprised to hear that the globe works because water finds its own level. And I'll explain a little bit more of this now. Ruhif has a video that he's explained this using a GeoBro model, and we'll come to that in a minute. So right now, the other thing I got to deal with is No Fanfare thought he was being very clever with this. He thought he'd got me on this one. Is there any difference between two flywheels? One with a Spherelinder, he just means flat edge. Forget this Spherelinder talk. And the other with a chamfered edge, which he means the curved edge, depending on how fat your slice of the Earth is, you will notice a curve or not, but it has a chamfered edge. Put a drop of water on them and then spin them. Do you think the water on the chamfered edge would make its way to the higher part? And don't scribble on some paper and do a practical test. Right. So, yes. So I say, yes, I'm so glad you brought this up. I agree that there is a chamfered edge. But we never got to discussing the shape of the edge because P-Brain was too busy being an idiot. He's too much in a hurry and a rush to say, oh, look, I got you on this. So I was never able to finish the explanation. So there are facets that they haven't considered, and they are the forces involved. So I've got a diagram here with the so-called chamfered flywheel, which we would do a cylindrical section from the globe Earth, and then it would have one radius would be slightly smaller than the other one for this cylindrical section. And so No Fanfare is saying if you put a drop of water on it and turn it, the drop of water will move up. That would be correct for a flywheel on the surface of the Earth. But that's not correct for the Earth itself, because the direction of the force that holds the drop of water to this surface is always perpendicular to this surface. The force, the flinging force, the centrifugal force that No Fanfare thinks would be so great as to make the drop go up there is such a tiny, tiny force. Again, I've put there, that's 10 times the size of the vector there. So that's the size of the gravity vector. That's how much force is holding this drop to this chamfered edge. The force is perpendicular to the chamfered edge. Therefore, the drop cannot go up or down. So that's how the water stays in the lake. And we'll see a little bit more of that. I'll do another demonstration. So here I have a beaker or a jug, whatever you like to call it, with some water in it. Now, because the Earth is rotating, this is going at several hundred miles an hour. I'm at 27 degrees latitude, whatever that is, 700, 800 mile an hour, I don't know, I don't care. But it's perfectly still, so it's in a state of equilibrium. So water has found its level. Now you might say, but it's not rotating. Well, science says it is. So battle with the science if you like. So now I'm going to introduce a lateral force on this beaker. Now, according to P-Brain, the water should slam into the side of the beaker and possibly swash all around and get spilled over the edge, just like you saw in that swimming pool, right? But with the slowly rotating oblate spheroid that is our Earth, the water will find its own level and will reach equilibrium. So let's introduce a lateral force on to this beaker. Here we go. Now you see there's an initial movement that caused some disturbance in the water, but the water didn't rush to one side and slam up against it. It's reached an equilibrium state. Now, the size of this force is like 2 to 3 newtons, but normally in a lake would be experiencing 0.02 newtons. So it's reached a state of equilibrium. It doesn't move, and then we remove this sideways force, and the water adjusts, and there it's all completely still again. That's the principle of finding equilibrium, and that's how it happens on the bigger scale on the Earth. So just remember, this is what P-Rain thinks should happen.
When the ground rotates out from under your water, you have turbulence, and that's what you would have. Hundreds of mile per hour moving water would want to move in a straight line as per Newton's law. First law of motion. An object will tend to stay in motion at a constant speed and in a straight line unless there's something to act upon it.
So I mentioned before Ruhiv video. I'll put the link in the description. You can go watch this, and Ruhiv explains how the equilibrium is attained when the water moves towards the equator. Now, so I've done the maths a little bit. It's just to help with this. So what this means is that the equator is a little bit wider than the pole. So at 60 degrees latitude, I can work out what the radius is, and as I move towards the equator, the radius will get a little bit bigger, so the water will be higher towards the equator, and it's just a little bit higher. It will cause it to be level in relation to the perpendicular force, the result of the combination of gravity and centrifugal force will cause the water to have a little bit of a slope in it. So the Earth is wider on one side of this slice of Earth, and that will cause the water to maintain equilibrium, just like in that jar. So I'm just looking at this here. I've just say your lake is 1 kilometre from north to south. Now I've got the calculation of the forces. So the gravity force there is about 9.8 newtons. The lateral force, which is the centrifugal force pulling it towards the equator, is 0.0255 newtons, and the ratio of those, the centrifugal force is 0.259% of the force that's pulling the water towards the center of the Earth. Now, we would expect there to be then an approximately 3 metre height difference or radius difference between the north and the south parts of the lake. So using that formula I've just shown, these are the calculations for the radius at 60 degrees and the radius at 60 degrees and 1 kilometre. And you can see that towards the equator is 3 metres. 3 metres more radius, which is exactly compensating for the pull towards the equator. So the water is just got that little bit of a slope on it that causes a gravity potential that adjusts the downward vector, so the water adjusts its surface so that it is perpendicular to the downward vector, and that's a point of equilibrium. And no, the water does not slam into the side of the lake, it just maintains equilibrium. If there's a force that pushes it in a direction, it will follow the force until it's balanced out. So that's how it works, flatties. That's why we can see still water on a slowly rotating globe. So what do we got here? So in some of the comments. Look, I'll just quickly go through this. I was happy to admit if I was wrong and show me the evidence. So P-Brain's evidence that I'm wrong is this: northern latitudes. Okay. What's northern latitude? How am I wrong? What's that mean? Ground turning left. Okay. That's your saying that a latitude line is turning left instead of just turning in a circle. So, water, air, etc. Well, no, I've pointed out that the water, as per Newton's first law of motion, it's behaving exactly as we expect when you take into account the forces. So he's thinking the water should be moving straight, but no, it's got a centripetal force acting on it, the force of gravity. So no, it should not be moving straight. So they're wrong. And glass-like, mirror-like water when the wind's not blowing. Well, no, I've just shown you how water reaches equilibrium. And so because of all these faulty things, all faulty ideas, not taking into account force, etc., he just, without any calculations, without any measurements, without any thinking, right? No science, just a thought experiment, just some idea in some flattie brain. This is impossible and impossible. You're wrong. No, we're not wrong. I've shown the science. Again, he reiterates, all that dead, still water you see when no wind is blowing debunks any sort of Earth rotation. No, it doesn't. I've just shown, by indicating the forces involved and how it all works, that it doesn't. If you've got anything other than just empty words and word salad here, so the final experiment requires rotation. No, it doesn't require rotation. It demonstrates and provides evidence for rotation. The final experiment is evidence for. It does not require. Dear oh dear. Oh, the delusion, the self-delusion is incredible. Oh, so here's another one that says the water should rush to the equator. So, no, all right, the water makes a hill, Michael Dunleavy. I see you're trying to defend the science here, and P-Brain did a video mentioning you because you tried to defend the real science. So anyway, and yeah, there's no rush to the equator. The forces involved are insufficient. So P-Brain is chastising me because he thinks I don't know how my spinning sphere Earth works. P-Brain, you're the one. You are the one that doesn't know how it works. So I so wrongly state that latitude lines are traversed straight. So okay, when a object is travelling around a circle, if you turn the circle on its side, okay, they're making a turn. But if you turn the circle on its edge, they're going straight. But never mind, that's irrelevant really. It's the forces that are involved. But you want to make a big deal out of this turning or not turning. It's inconsequential. So he's debunked me by this diagram here. So he's drawn a straight line on this latitude line, and he says, look, the latitude line is not a straight line. And if you were to follow this straight line, you'd follow a great circle. Well, that's okay, but you've turned the globe. If you just turn the globe on its side a little bit, you will see that this one that you say is straight will be a circle, and the other one that you say is a circle will appear straight. So it just depends on where you're looking at on your circle. So that's a nonsense argument. So, well, that's all for today. So the donations are still open on the GoFundMe. The link will be in the description. And thank you very much for the people who have donated. This is a big help to me. And, yeah, if you do like what I've presented, please do donate. I've got a lot of work to do. I've got a lot of documentation to get through, all the rest of the stuff for the trip to the final experiment. I've got a lot of work to do, and I really appreciate your help because this is all I do. I'm retired, and yeah, I'd if you can spare a few bucks, that would be fantastic. Thanks very much.